The Multiband Pro takes stereo placement seriously. It can not only be used to change the stereo width and placement of the left and right channel, but you can also choose to pan other channels if they are available. Simply assign the left and right rear channels to your virtual stereo speakers and you can take care of the rear stereo placement, for example. You can also invert the phase of each channel and you can swap the assigned channels, as you can see in the output meter, although it is not displayed in the Multiband display. By the way, a great feature I have not mentioned yet. You can solo each channel in the output meter of each Vienna Suite Pro plugin. Center and width of the stereo triangle are displayed below the main display and can be edited with the mouse. And as with all panning and balancing plugins, you can set the pan low value, which determines how the signal levels are affected by panning when they are panned closer to the center. If the Balance Before Pan button is activated, the balance section below will be processed before power panning. And of course, both assigned channels can be mixed to mono. Let's get to the balance section, which offers quite some useful panning effects. Each control below the balance amount fader affects the strength of the chosen effect, which is then scaled with the amount fader. So amount is the master balance fader. It applies the set amount of the balancing features below in percent. Gain balances the gain. Balance is commonly done by adjusting gain alone. A simple but very accurate classic panning. Delay lets you create a Haas effect. At 100%, the maximum delay is 50 milliseconds. And this is how it works. If the amount fader is set to 100% and delay is set to 100% as well, you get 50 milliseconds applied to the left channel. If the amount fader is set to -100% and delay is set to -100% as well, you get 50 milliseconds delay applied to the right channel. Spectral balances the spectral change. It applies shelving filters to raise or lower high frequencies. And phase applies a phase shifter to one of the channels. At maximum settings, the phase shifting is 180 degrees. The workflow could be like this. Set how much of each panning effect should be in use, then adjust the amount slider to find the right position. Just like the Multiband Pro, the Imager Pro lets you select the channels for your stereo speakers. You can invert the phase of each channel and swap the channels. Also like in the Multiband Pro, you can see the real-time audio angular analysis of the processed signal. With the Imager Pro, you can change the width of the stereo image and the rotation of your signal by dragging the edges of the stereo triangle, so you can easily widen your stereo signal. Shuffle increases the stereo width at bass frequencies, which can be adjusted with a frequency knob from 350 to 1400 Hz. Choose a frequency between 600 and 700 Hz for classic stereo monitoring. Higher frequencies may be better if the playback is aimed at loudspeakers often used in portable playback devices like laptops, where the stereo speakers are very close to each other. If you used stereo microphone techniques where the microphones are spaced apart 30 centimeters for your source file, lower frequencies will be useful. Of course, the Imager Pro is fully phase compensated. The Goniometer Pro is a great tool to display the phase differences between two audio channels, resulting from the similarity of the signals. You get a scope reading of the selected speaker's signals to get an overview of the amount of out-of-phase signal parts. The correlation indicator offers a simple solution to check the monocompatibility of a stereo signal. It also lets you identify unwanted phase shifts or polarity inversions. The main display window shows the interpretation of the chosen signal, with the correlation glow meter displaying the correlation of the input signal in a range from -1 to +1. +1 means that there are identical signals in both channels. +1 to 0 means that the input signals are more or less monocompatible. 0 means that the input signals are totally uncorrelated, or a channel is missing. 0 to -1 means that the input signals are not monocompatible. -1 means that the input signals are identical, but with polarity inversion on one channel, so there is no monocompatibility. Just like in the PowerPan Pro and Stereo Imager, you're not actually restricted to stereo signals, but you can select your speaker channels from any multi-channel format. Again, you can invert the phase of each channel and swap the channels if you like. And the glow feature enables you to control the signal without constant observation of the display. You can adjust the glow time for the correlation glow meter and the Goniometer Pro main display separately. You can deactivate the interpolated signal that simulates analog goniometers. And you can reduce the amount of drawn points by a factor of 4 if you like. Each signal is normalized before metering by default, but of course you can switch that off. The Loudness Pro measures loudness similar to the human perception of loudness and is used to compare different audio material from a technically calibrated standpoint. It is adhering to EBU R128 standard and well suited to monitor the loudness in live and broadcast applications just as well. Adjust the scroll rate of the metering timeline and the reference level for the loudness unit metering right above the graph display. The ITU average level is at -23 decibel. That's also the default setting. Choose between loudness units related to full scale, LUFS, or loudness units, LU, for the scaling of the integrated, short-term, and momentary values. Sync synchronizes the Loudness Pro with the host transport. It resets the values on transport play events. The graph window shows the graphs for the parameters displayed below. Like in the Analyzer Pro, you can click-drag to zoom in and right-click to reset the zoom. Of course, you can also decide which of the parameters you want to see displayed in the graph window. Integrated displays the actual perceived loudness averaged across the signal that passes through the plugin. While short-term displays the perceived short-term loudness, measured over the past 3 seconds. The momentary loudness levels of the past 400 milliseconds are displayed in the next cell. Range displays the overall loudness range that passes through the plugin in loudness units, measured since the last reset. And True Peak displays intersample peaks which do not register in the sample data but may occur during the reproduction of the digital signal. These values are shown in decibel, relative to full scale.